and I'm going to present a part of my research on the topic, analysis of talking parameters of natural antioxidant resveratrol with glutathione peroxidase and cytokine TNF-alpha, and its comparison with the in vitro studies done on osteoporotic patients. Now, to begin with, as you all know, that osteoporosis is a progressive and a chronic disease of the skeletal system characterized by bone fragility. Here, patients are seen to have an imbalance between the generation of reactive oxygen species and the body's ability of the antioxidant system to efficiently combat it, thereby leading to a condition of oxidative stress. This oxidative stress-like condition then augments the levels of pro-inflammatory markers like TNF-alpha, interleukin-1 beta, which then starts acting synergistically on each other, thereby leading an increase in the bone markers. And this, in turn, augments the activity of the osteoclasts, and hence we have the pathogenesis of osteoporosis. My present work basically attempts to regulate the production of reactive oxygen species in vivo by the natural antioxidant resveratrol from grapes, having potent antioxidant as well as anti-cancer activity. So the basic aim was to somehow curb the generation of these free radicals, which are produced in various biological reactions in our body, which leads to oxidative stress, which is the main culprit of osteoporosis. The antioxidant that we have employed in our study is resveratrol. It is a phytoalexin, which is found in various fruits and berries like mulberries, strawberries, red wine, grapes. It is basically consisting of two phenolic rings, which are bonded by a double styrene bond. The strategy algorithm that we try to adopt over here is that we know in normal healthy individuals, there are not accelerated levels of osteoclasts, and there is a kind of homeostasis that is maintained between the osteoblasts and osteoclasts, thereby the persons are having healthy bones. But in conditions where the reactive oxygen species levels are somehow increased, which then activates pro-inflammatory markers, which then start acting synergistically on each other and augment each other's level and exerts continuous effect on other bone markers, and then ultimately leads to osteoporosis. So if we try to give this resveratrol antioxidant as a treatment to neutralize the reactive oxygen species, this in turn will somehow downregulate the production of pro-inflammatory markers, which in turn will have no influence on the other bone markers like osteoprotein, rankel, osteopontin, osteocalcin, and thus the accelerated osteoclast differentiation will not take place, and the accelerated bone resorption will not be there, and hence we can somehow delay, if not completely cure, the onset of osteoporosis. After doing the in vitro studies, we also validated our results by doing docking analysis. The HEX software was done for the docking analysis. The 3D conformers of resveratrol were obtained from PubChem, and the target proteins and the resveratrol's interactions were further visualized by PyMod. Regarding the patient's clinical information, our inclusion criteria was the patients with radiologically evident osteoporosis or patients with low bone mineral density. Menopausal state in women was determined by their clinical history, and exclusion criteria was the patients which were having previous treatments with hormones or any sort of drug that was active on bone metabolism. So the section A of our study was, first of all, to assess that whether or not the osteoporotic patients are under oxidative stress. And as we have studied in various previous studies and literature review, it was found that the glutathione peroxidase levels, which is an antioxidant enzyme, was highly compromised in the osteoporotic patients as compared to the healthy controls. A similar situation was seen in the intramonocyte glutathione levels of osteoporotic patients in control to healthy individuals. The level over here was also significantly decreased. At this point, we tried to administer the natural antioxidant resveratrol. But as we know that before employing any sort of antioxidant or any drug, we have to assess for its cell viability, which we have done over here through entity cell viability assay. And resveratrol doesn't exhibit any sort of adverse or toxic effect in 24-hour culture studies. But at 48 to 120-hour culture studies and at a dose beyond 50 micrograms per ml, the cell viability was seen to be reduced. So we carried out further studies with 24-hour cultures only. Next, we tried to administer resveratrol on osteoporotic patients and look for its effect on glutathione peroxidase enzyme in the osteoporotic patients in 24-hour culture. And at a dose of around 40 to 50 micrograms per ml of this antioxidant, it was seen that there is a sufficient amelioration in the glutathione peroxidase activity. A similar situation was seen in case of glutathione as well. At a dose of around 20 micrograms per ml of resveratrol, a sufficient amelioration in the GFH levels was also seen. The third part of my study basically aimed in basically producing osteoclast precursors directly from the PBMC. Here, the studies have shown that after the 3-day culture duration in osteoclastogenic medium, the multinucleated osteoclast precursors were observed to appear, and the number of such multinucleated cells reaches to their maximum after 5 days of culture, which was assessed by trap staining. This is basically a 20 graph representing the 24-hour culture, 72, and then highest at 120. At this point, we tried to look out for the effect of resveratrol on this culture, and it was seen that co-culturing of PBMCs with resveratrol at a dose of 20 micrograms per ml in osteoclastogenic medium, both in 3 and 5 days, resulted in an appreciable amount of reduction in the appearance of multinucleated osteoclast precursors. So this shows the potential of the above supplement having antioxidant property to exert effective regulatory effect in osteoclast generation and differentiation. These are the graphs representing the 20 micrograms per ml of resveratrol administered for 3 days and then for 5 days. There is a marked decrease between the two levels without resveratrol and with resveratrol. And this 20 micrograms per ml of dose, we have reached to this conclusion by doing a dose response effect. As can be seen, at a dose of around 20 micrograms, the number of multinucleated cells was significantly decreased. And in terms of percent inhibition, at 20 micrograms, there was a maximum percent inhibition in the number of multinucleated cells. Now, the second last part of the study was the immunological investigation. As can be seen, in comparison to healthy controls in osteoporotic patients, there is an appreciably augmented levels of both TNF-alpha and IL-1 beta in monocyte culture supernatant of osteoporotic patients. But with the administration of resveratrol, both TNF-alpha and interleukin-1 beta levels were downregulated. However, in healthy subjects, the low levels of both of these cytokines remained more or less unaffected. The last part of the study was docking analysis. To validate the studies in vitro that we have done, we have done the docking analysis, and it was found that the binding energies of both GPX as well as TNF-alpha with resveratrol were very high. These high binding energies with natural antioxidants employed over here further confirms or validates our results. These are the docking images of glutathione peroxidase with resveratrol. The structures are stabilized by hydrogen bonds, van der Waals forces, and pi interaction. This is with TNF-alpha and resveratrol. Now, to conclude, we can easily say that there is a high magnitude suppression in glutathione peroxidase activity as well as in glutathione levels in monocyte cultures of osteoporotic patients. Resveratrol dose-dependently ameliorated the suppression of these glutathione peroxidase and glutathione levels in the patient. The active oxygen species mediated activation of monocytes of osteoporotic patients resulted in the induction of augmentation of the basal levels of TNF-alpha and interleukin-1 beta. However, resveratrol was efficiently able to downregulate the levels in the monocyte cultures of the osteoporotic patient. A dose of 0 to 100 micrograms per ml of resveratrol failed to show any adverse effect in 24-hour culture in osteoclastogenic medium. However, the cell viability was affected in 48-hour cultures at doses above 50 micrograms per ml. And resveratrol at a dose of around 20 micrograms co-cultured with PBMC in osteoclastogenic medium for 3 to 5 days resulted in an appreciable amount of suppression in the appearance of multinucleated osteoclast precursors. This exhibits that resveratrol has a potential antioxidant as well as anti-resorptive properties. And our docking data further shows strong binding energies of glutathione peroxidase and TNF-alpha with resveratrol, and our experimental in vitro data are in synergy with the docking data. Hence, we can easily conclude or suggest that natural antioxidant employed here and the findings so obtained would prove to be of great help both economically and in terms of safety in the management and the treatment of osteoporosis. Thank you.